Module 4, Section 2, Building a Custom Module. So let's go to our IDE and let's start building our rock, paper, and scissors module. Before starting to code, let's recap real quick all the folder structure that we have in our project. There's this app directory that holds the core application file that we already mentioned, where we have our application and the necessary wirings and modules to make the chain work. In here also you will find an export.go file that is in charge of exporting the current state of the chain as a Genesis file. And also there are some configurations to set up what's the chain denomination, in this case RPS, and the addresses prefixes for the different type of addresses. These functions just set the different addresses to be used globally within the application. Then we have this encoding struct used to specify the concrete encoding types to use in the app. And then we have this CMD directory that it's basically the binary that we will be building, that it's the rpsd command. If you go to the root command here in CMD, you will see that here we define the name of the rpsd and we wire all the dependencies here with the dependency inject. This will wire up all the modules, the specified modules in the app.yaml. Will wire up all the modules commands as well. And then we have these commands where we are putting together all the different commands that we need, for example, for the Genesis, for initializing the chain, for debugging, pruning, creating snapshots, and other utility functions. The keys, this will help us manage the keyring. And here you have the definition of the query command and the transaction command that would give us other subcommands for the different modules. For example, here you have the transaction command where you get all the different commands to sign and broadcast transactions and encode transactions, as we saw previously. Then there's the script folder that we already went through with the init script, and in here is the X directory, that is where our custom modules will sit. Then we have the Go mod. As we saw, we have out here the dependencies, and this is the Go sum of that depends of the Go mod and all our dependencies, and that's pretty much it. Now let's start with our module. So we have to add here our custom modules under the X directory. We're going to add here a folder that it's going to be the name of our new module. I'm going to call it RPS for rock, paper, and scissors. And in here we can add a README similar to this one to write down here the specifications, how our module is going to look before starting to code. So this is going to be an RPS, and we can say here rock, paper, and scissors module. We got here some description of what this module does. I'm going to do this later. But for now, let's define our state objects. These are going to be the objects to persist in this modules store. So in our case, we're going to store each of the games. There's going to be 2 players playing one game, and each game is going to have a certain count of rounds. When a player wins the majority of the rounds, the status of the game changes to finished with a winner. So the state object, it will look something like this. Our state object is going to be called a game, and it's going to contain the following fields: uh, game number, that's going to be the ID, it's going to be an integer. Then we will have a player A and a player B. These are going to be addresses in the chain. Then we are going to have a status field that would be a string. And we are going to have the number of rounds for this game. It's going to be an integer as well. We can actually make this uint because there are no negative rounds and no negative game number. And then we are going to store to keep track the player moves. So we're going to have player A moves. That's going to be string slice or string array. And the same with player B. So we have a track of which were the moves for each of the players, and we can verify that the result is correct. And we'll have a score. We'll keep a score for each of the rounds, for each of the players. So it's going to be an array, a tuple actually, that will have the score for player A in the first place and the score for player B in the second place. And that's pretty much it for the game object. We will be storing all this information in the module store. Also, we have to define here the different services, the message server to create or interact with the games, and the query service. So let's define this message service. We are going to have a few messages. So we're going to have one to create game, that's going to have a creator, that would be an address, which is the signer of the message. And we will have an opponent, which should always also be an address within our chain, and the number of rounds for the game. That's going to be an unsigned integer. And the next message that we should include is a message that allows to play again. We are going to call it message make move. And in this message, we will have the player that makes the move, that is an address, and it would be the signer of the message. And we will have a game index or game number, that's the number of the game that we are playing. So it's going to be a uint. And the third field is going to be the move, if it is either rock, paper, or scissors. So in here we can specify that this should be always one of the valid options. And that's pretty much it for the message service. And now we define the query service, that to make it simple we will only have one get game query, get game by ID, that would get a input parameter, the game number. Additionally to the module specific state object, usually SDK modules have a state object called params, where parameters specific to this module are stored. In our case, we are going to add this state object, but for now we're going to leave it empty. Later on, we will add a param here for a specific functionality that we are going to add to our module. In the same way, we should add a query so users can query which are these params at the moment. So we'll have a get params query. Besides the query service and the message service, we should specify here which are going to be the events that this module can emit. We're going to have an event emitted when a game is created, that we're going to call it event create name, create game. And this event is going to have three fields: the game number, the player A address, and the player B. This is going to be an address. The same for player B. The game number is going to be an unsigned integer. Then we're going to emit an event end game when a game ends, and we are going to specify in this event which game number finished and the final status of the ended game. And finally, we're going to emit an event when somebody makes a move in a game. And here we're going to include the game number, the player that performed the move, address, and the move itself, move string. Obviously, this event create game is going to be emitted once the message create game is executed. The event end game will be emitted when a player wins or loses a game, and the event make move will be triggered whenever a player submits a move with the message make move. Now we have all the basic structure of the module, but let's look into some reference to understand what is the folder structure of a Cosmos SDK module, so we can get an idea of how organized our code. In the README, you will see a reference to Cosmos SDK module template. There's the Cosmos registry/example in the GitHub repo. I have it open here. You can have this repo as a reference. However, I'm not going to follow exactly this same folder structure because this template is more for a standalone module. You can see that here it has a Go mod for this specific module and have some of the generated protobuf files that usually these go in a types folder. So the, all the files are pretty much the same that we are going to add to our module, but the folder structure is a little bit different. But anyways, you can have this as a reference, and we will getting from here some scripts and YAML files needed for the product generation. So from here, we're interested in this product directory where we have these YAML files. These are usually standard YAML files used across any Cosmos SDK application. So you can just copy and paste all these in our module. So we can add here in our root. We'll add a proto folder. This proto folder is going to contain all our custom modules protobuf files. And in here we have to add these different templates file. What's the name of this one? Let me see. Buff gem go YAML new file, and then we can get this. And there's another one that we should get, that's the buff gem pulse or YAML. We're going to add it in the same directory, in the proto directory. All these YAML files will work as a template when we generate our Go proto files. And in the script, you will see this proto-gem.sh script that we will need as well, and we are going to place that one in the scripts directory. And in this case, this one is specific for your repo. So in here you have to change this Go package to be RPS chain, that it's our repo. And the same for here. This is going to be our LB RPS chain, that it's the same number name that we use here. So if you're using a different one than this, you should put this module number name from the Go mod. And for now, this step we're going to comment it out, because at the moment we don't have any custom protos including our product directory, so this doesn't have any effect, but we'll have to edit this later. Update to correspond directory. We'll work on this later. Okay, so we have the scripts that we need, and then we can build the folder structure. We are going to add a keeper directory where our keeper is going to be, and the keeper methods. In our RPS module, we'll add a new folder called keeper, and then we will have migrations folder where all the migrations will sit when we make an upgrade. And from the proto directory also we'll have to copy these two files, the buff.log and the buff.yaml as well. Let's do this. In the proto directory, let's add the buff.log and we can add the content for the log file. Not the log, copy. There you go. And the other one was the buff.yaml. Let's add it here in proto new file buff YAML, and we get what we need. Okay, now we have everything set up to define our proto files and then generate the corresponding Go proto that we can use in our application. Let's start with our proto files. Inside the proto file, the proto directory, we'll add a folder that's going to be, we're going to call it LB for learning blockchain, and in here we will define the module name, in this case RPS. If, for example, you want to add another custom module to this chain, you will of course add it here in the X with the name of the module, and then for the proto files corresponding to that module, you should add it under the LB. So let's now define our proto files for our module. In the module template example, you'll have some material for reference. If you're using the dependency injection for the app wiring like we are doing here, if you go to our app.go file, you will notice that we are using this depth inject. Also, we're using this to wire the whole app and the different keepers and modules, and as you saw previously, also all the CLI commands. This dependency injection method is just one possible method to wire up the app. Later on in the course, we will learn another way to do this. But for this dependency injection to work, you will need this specific Protobuf file called module proto. So for us to work with our custom module, we'll have to add this proto file. So let's add it for our module. So in proto, under LV RPS, we'll follow the same folder structure here. In this case, Cosmos registry is the owner, and example is the module. So we'll add the module v1 module proto paths. So this is going to be module and v1 directory, and inside the v1 we will add our module.proto, so we can use this module using dependency injection. The module proto is pretty much the same for every module, so we can copy this and update here the package to be our package name, lb rps module v1 and the same here for the Cosmos registry. This should be RPS chain X RPS. And then we can add for the module here RPS. So that's it for the module v1 directory. Now in Under the v1 directory, you will see all the protos related to the types of this module, the query server, and the message server. In our case, we are going to structure it a little bit different. Instead of having these types proto, we're going to call with the name of the module. That's a naming convention that you will see on Cosmos SDK modules. So I prefer using that structure rather than this one, but it's the same. So let's go to our proto LB RPS, and in RPS we're going to add a v1 where all our Protobuf files are going to sit here. And let's create an rps.proto, and in here we're going to define, for these imports are pretty much the same. We can copy this first part, that's going to be repeated and update here lb rps chain, same for the module here rps lb. Keep in mind that this lb refers to the folder. In here you see it's the same path that we are having under the proto directory. It's lb rps v1, and we are having this same path. So if you are naming this folder differently, make sure to update here in the package the folder name corresponding. And the Go package, it's the Go mod module name. It's this one. So we should add here. And for this case, we're going to place all this into our types folder. What this is going to do, when generating the corresponding Go files from the protos, it's going to place it inside a folder called types under this path, our repo, and then X RPS types. And for us, we don't need this option for amino name. We can remove this dependency and keep only the Cosmos Proto one. For now, we will leave it empty, and then we have to define our game state object. Game defines the rock, paper, and scissors game object. And here we will put all that we already defined in our README, all this. So let's do this. RPS, and we'll have a uint 64. It's going to be game number, and it's going to be the first field. Then we'll have a string that's a player A place 2, and here we will add this annotation. Cosmos has some useful annotations, for example, to specify that this is going to be an address. We can do the Cosmos address string. You can get a list of the available annotations in the documentation. For player B, it's the same. We're going to use 3 here. Then it's going to be another string with status. It's going to be number 4 field. Then we'll have a uint 64 to define the number of rounds of this game. It's going to be field 5. And then we're going to have the the moves for each of the players. Player A moves is going to be field 6, and field 7 is going to be player B moves. And finally, we're going to have this score. It's a repeated UN64 score field 8. Cool. So we have our store object defined here. Everything looks fine. And the next proto that we're going to add, that it's not included here, but you will see in other Cosmos SDK modules, is a Genesis proto file where we'll define the Genesis object used on Genesis. It's a simple file. The Genesis proto is going to have the Genesis state. We'll need to have all this. We can copy and paste, and also then we will use the Google proto dependency, and we are going to also use the types that we just defined in the rps.proto. So v1, here we're going to pick up the params and the game from this file, and we also have to add the option go package. Then this will drop the generated files in the types. So we have a message Genesis state. It's the Genesis state of the, let's add a comment here, Genesis state defines the RPS module's Genesis state. And this Genesis state is just going to have a params, let's say module params, and we are going to add this Google proto nullable false annotation, and then we are going to have, let's add a comment here, params defines all the parameters for the RPS module, and then we'll have a games field that are the stored games in the module. This is useful because if you are starting from a Genesis where there are already games created, you will need this structure that it will be generated from this proto file. And it's going to be an array of games being in the object that we defined in the previous one, and we're going to add this annotation as well. And that's it for the Genesis state. And now we can define the transaction and query message service. So you see that in here they define a service with two RPC methods, two messages. So let's do the same. We can take this as a reference to our transaction proto and then make the corresponding changes. New file transaction.proto. Here it's going to be LV RPS v1, the go package the same as the previous ones. and this one we will not need it because it's something specific to the example, and we are not going to use any amino annotations, so we can remove that and keep this, but we will need our types that we defined previously: RPS v1, RPS proto, and define our message service. For now we're going to leave it empty because first we have to define our different messages. We'll have a message create game, defines the message create game request type, and it's going to be message create game, and it's going to have a signer that's going to be the creator field, as we mentioned previously. Signer is going to be creator. Remember that in our README we define the creator, and then we have to add an opponent and the rounds. Those are the required fields. So we have a string creator. Oh, I forgot here to add the semicolon. In this case you can add if you want the annotation for the addresses, because this is going to be an address, but it's not totally necessary. They're going to have an opponent. It's going to be field 2. Let's add the corresponding annotations. There you go. And then it's going to have the rounds 3. And we're going to get a message create game response. It's going to be an empty message. We are not going to return anything specifically. And now we can add our RPC method create game message create game that returns message create game response. Create game creates a game. And now here I'm missing this tail. And now you can pause the video and do the same with the message make move. I added here already the make move. I hope you were able to do this, but it's straightforward. You have to define the message make move and the make move response. Another message that we should include here is the required message to update the params of the module. So to do so, let's create a message update params that defines the message update params request type, and we're going to have it's a message update params, and we're going to have a signer defined that's going to be the authority. Only the authority of the module will be able to update the params. There's a convention that the authority is always the governance module address, so you can only update a module's parameter via governance proposal. So we're going to have the authority within the message that's going to be an address, Let's get this annotation. And the second field is going to be the params. And we are going to add an annotation here. The Google Proto non-nullable, Proto nullable false. And then we have to define the response message, update params, response. It's going to be just an empty response. And let's add here the corresponding message, RPC update params message, update params returns a message, update params response. Straightforward. Let's add a comment here, update params update params of the RPS module. Again, keep in mind that this RPC method can only be called via governance proposal. We will see later on how we validate this, but this is not a message that any user can submit and change the params of a module. Next, we will have to define the query server. If you go to our sample, they have this query.proto, where you see they define their query server service with the different available methods to get information of the state of the module. So let's do this. We can get the imports are pretty much the same. Here we can pick up some of these and add the query.proto. And we will need here a Cosmos query proto from here. This will be useful for us. And we will also need the API annotations. And that's it, we need only this. Oh, it's already there. I will define our service query, and our messages are going to be message query get game request. That's going to have only an index. That's going to be the game index. That's the game ID. And we're going to have the response get game and it's gonna give us a game object. That's the requested game. And here we can define the RPC get game method that will have the query game request returns a query response. And also we'll have to add here the get params for users to query the params of the module. In this case it's an empty get params request, and the response is going to be the params that we defined in the RPS product. I'm missing here the semicolon. That's it. And we can add here the get params request. And get params response. And for the query service, there are a couple of useful annotations that we can use here. As you will see, you can here define and expose via HTTP this specific endpoint. So we're going to use these annotations. The get game, in our case, is going to be RPS v1 game and the index, and similar for the get params. We will see later on that we can get access this via the API of the application. And this is going to be a get to use params. Keep in mind that here you define the method, the HTTP method. If you want to make this a post or a put or whatever you want to make it, you can change it here. So we're done with the query service. Now we have to find events. Similar to the previous cases, we can use this same header events, and we are going to have the events that we already mentioned here. We are going to have these 3 events: message, event, create game. That's going to have a game number, and the player A. I'm going to get this from here. It's going to be faster. And then we're going to have a message end game with game number and the status. And then a message make move. I tried to make move here before. Message event make move. This should be event and end game event make move. And we're going to have the game number 2 here. The player, that's going to be an address, player, and the move, that's going to be a string move, and this is going to be 3, and status should be 2. For those that are new to protocol buffers, make sure to read the documentation, but you always have to set numbers for the different fields. And if, for example, you change one field name, it can be backwards incompatible. So when you, for example, want to remove this move and add another one, I don't know, a new like game move, for example, you want to rename it, usually you use this reserved for the 3 and then you use a 4, but it's a good practice not to edit some field that's already there with a specific number. And yeah, in here I made a typo. It's event. Let's rename. 1, 2 events. And that's it for the protofiles. Let me see if there's anything else. We have all these already, and everything that we already wrote down in our README. So yeah, now it's time to generate the files. I forgot here to add a dependency to support these annotations. We can get it from this. This is the corresponding dependency. This should be all set now. Now that we have all our profiles defined, and we have also our script to generate the corresponding files, we should add to our makefile a command to make it easy to generate all these files. For this, we can go to our module example repo, and if we look into the makefile, you will find like there's this section defined Protobuf that this will perform different operations with the proto files. It's going to generate the protos files, but also we can use it to format and lint our proto files, and all these operations are performed when we run the make proto all. Let's add this protobuf section to our makefile. In here we will add protobuf, and something useful also that we can copy from this as well is the linting for Go files. This may be useful for us as well, so we can put it in here as well. So there's one more step that we should do before running the make proto all to generate our files, that is updating this to the corresponding directory. So in here we'll remove this comment, and in our case our proto files are going to be generated in an LB RPS. Actually everything that's with the LB, because we can include other custom modules. So we're going to copy all this and we are going to paste it into the API directory. Then we are going to add it here as well in the root of our project. Let's add an API directory. When running this protogen script, it will generate all these files into a directory called github.com and a directory called lb. So we're going to move all these to our types directory for the corresponding module. That's what this step is doing. And the generated files will look something like this. For example, the query.pb.go and the .pb.gw.go files. In here you see that they have this API folder as well, where we will have these pulsar.go files. So now let's run our make proto all command. So it formats, lints the proto files and generates the files. We got this error because we don't have this defined, the Docker variable defined, that it is, let's go to the make file. You will see that it's defined here. We should copy also this variable, and let's give it a try now. Make proto all. and we get some linter issues. Let's see what these are. So we're getting this error, this linter error about one of the annotations, a non-extension go proto nullable in the transaction.proto. I believe we're missing a dependency here. You see we're using this go proto, but we don't have here the import, so we have to add it. The go proto, I think we had it here. Now let's try it again. We get another issue. Extends, should extend product service option in the query one. Let's see what the issue is here. And here the syntax is incorrect. We have to add here the options within these curly brackets. This should be within this, inside the method. Let's do the same for this one as well. Move this inside. So let's try it again. Now we get another option. Oh, these are mostly for, yeah, we should add comments for each of the different, you see, for example, for the events. So I will add real quick some comments. Get game returns game at the requested index. Get params returns the RPS module params. Get no game request is the request type for the query get game RPC. Let's is the response get params. This you can copy if you don't want to do this at the same time. You can copy it from the commit that we're going to do. And also we have to add some comments to the events. Is an event emitted when a game is created. It's an event emitted when a player makes a move. It's an event emitted when a game ends. Let's see if we have all of them covered. Service query. Query is the query service for the RPS module. And let's see now if we pass the linter. Still have some empty comment for create game. Okay, for the transactions. Response. for the response. This actually should response typo response, and the same for this. Let's copy this comment for the message. Update params. Update params. It's a little bit annoying, the linter, but better to have this. And we have one more. The query get params. Now should be named get params. Params. We have some. Oh yeah, params. No, get params. Alright, now it's generating our files. Okay, no such file or directory. Okay, so I found what the issue is. This protocol buffer generator doesn't like us to have this name for the package to have a dash here. That's what's breaking. So we're going to change in the debug mode. Let's remove this dash and it would be RPS chain without the dash. And let's do the same for all these different files. So it's going to be RPS chain here. In here, we are going to remove that dash. There you go. And let's make sure there are no any other left with this RPS dash chain. We have it here and in here as well. And also let's remove it here. And we can update this to be 0xlb RPS chain. There you go. Now let's give it a try. I commented this out before, and here this is from the template, but it's actually the LB. Now let's give it another try. Make proto. Let's see now if it generates. No such file or directory. It seems that it's not generating yet. Let's remove that for a minute and see what's going on now. Let's generate, only generate. Oh, it seems that it's picking up this somewhere. Let's search again. This should be without the dash. Should be. It's here. We have to update these imports. And after this, hopefully, fixes the issue. Now let's try again. But it seems that it's not yet generating the files. The issue is related to some permissions on Docker. So to fix this, if you're encountering the same issue, is, well, first we have to fix this to skip this folder RPS API when generating the products. So we have to add here slash API, and then in the make file we will add here. The problem that we're having is that when running the Docker command, the user that picks up Docker does not have permissions to write. I'm having this issue, not sure why, but the workaround is to run the command as a root user, so we will write the corresponding files. And the solution to this is adding a flag that's user 0 that will force the Docker command to use the root user. But to make it general for people that this is working for you, we can add here an optional flag. And then if you're having this issue, we will run the command with the corresponding flag, in this case proto flag, and we're going to have user 0 to use the root, and then make proto gen, and you will see that here you generated a github.com directory and an lb directory, where here we have our .pb.go files. This is what the script is doing when it's running the buff generate command. But we uncommented this, that this what it does is putting all these files, in this case all these files are going to go to types. You see that the whole path is RPS types, and this lb module and the .pulsar.go would go inside the API. So let's uncomment this. So we move these files where it should go, and we run it again, the user flag, and now we should place those. You see now it placed this into the API, and then we have the other ones in types. Here we go. An additional step, if you had to run this command with the u0 flag, is changing the owner, because right now those files, if we check, are created by the root. And for us to make it to be easier to work with this and don't have to use sudo command, we can change the ownership of the whole forward files. To do that, we can use this command in sudo. We're going to update all the directories recursively to use our user with this. Now we're good to go. If you check it again, types, we will have our user. Keep in mind that if this was working for you without having to use the U flag, you would not need to perform this step. This is just a workaround to the issue that I'm facing. Now that we have all these proto files generated and the corresponding script set up, let's create a branch and commit these changes, so in case you are encountering any issues, you can start from this commit. So let's create a branch called lesson 1, and let's add everything. Add proto files and scripts. Let's push Alright, now we can continue with our boilerplate code to be able to wire up our module.